The aim of this video is to help you draw Lewis dot diagrams easily and simply. The first one we're going to look at is H2O. So remember, the idea behind Lewis dot diagrams is to try and work out how the atoms that are in the molecule are arranged or attached to each other, bonded to each other. The very first step that I do when drawing Lewis structures is to look at the periodic table and count the number of valence electrons. So really simply, we can, if we look at the periodic table, we can see that there is a group here, group 1, group 2. Now if I keep going across the top of the periodic table, group 13, if I add a 3 here, group 14 is a 4, 15 is a 5, 16 is a 6, 17 is a 7, and 18 is 8. For most of the molecules we're going to draw, they're going to be found within these 8 groups or 8 columns. And if we look very quickly at the periodic table, the red number that I've written on top actually represents the number of valence electrons they have. So in this case, hydrogen is actually in group 1. It has 1 valence electrons, and oxygen is in group 6. Okay, you can just see that, to group 6 here. So it has 6 valence electrons. So I just put this back because what I want to do is work out the total number of valence electrons. So in this case, the total number of valence electrons equals 2 times 1 plus 6 equals 8 valence electrons. Okay. Step 1, count the total number of valence electrons. Okay, step 2, we're going to put the atom with the atom with the most unpaired electrons in the center. Now, since oxygen has 6 electrons around it, 2 of its electrons, let's just draw it over here. If I was to draw the electrons around an oxygen, there we go. Now 2 of the electrons around the oxygen are unpaired. If I was to draw the electrons around a hydrogen, there we go, just 1. 1 of the electrons is unpaired. So the oxygen atom is the most unpaired electrons. I'm going to draw that in the center, and I'm going to draw my other atoms around the side. There we go. This is step 2. So, step 1, count the total number of valence electrons. Step 2, place the most unpaired atom in the middle and the other atoms around the outside. Okay, step 3 is I'm now going to add add electrons to the outermost atoms. Now we add the total amount of electrons in its outside shell. In this case, hydrogen has 2 electrons in its outside shell, so I'm going to give hydrogen 2 electrons, and I'm going to place these 2 electrons between the hydrogen and the oxygen. Now the hydrogen has around it 2 electrons, so it has a full shell, remembering that the first shell of electrons has 2 electrons. So that's satisfied, it has its correct number. I've used 4 of my valence electrons, I have 4 left. I'm going to place the rest of the valence electrons around the central atom, which is the oxygen, and I'm going to place them in pairs. When we draw Lewis structures, we always draw the electrons in pairs. There we go. 2 of them in pairs. And that's my 8 electrons put into my molecule. Now what I want to check at the end here is I've used all of my electrons. I need to then go and double check that each atom has the correct number of electrons around it to fill its outermost shell. So hydrogen has the 2 electrons it needs to fill its shell. The other hydrogen here has 2 also. Okay, so we're happy with that. And the oxygen has 8 electrons adjacent to it or around it. Its shell, and this is the second shell here, is full. So all of the atoms here are satisfied or have the correct number of electrons around them. We can rewrite this now. Commonly what will happen is whenever there is a bonding pair of electrons between 2 atoms, they are drawn as a single line. We replace that and we put the non-bonding electrons either as dots or as crosses. Okay, so this is our final Lewis structure here. And that's how we draw the Lewis structure of H2O.